Hi everyone, welcome to my YouTube channel, and in this video we will look at problem 718 from Leetcode. So this problem, there are two ways of solving this, and the way I did it on my when I first encountered this problem, the first method I did was using dynamic programming approach, but then there is another way of doing this problem in more efficient manner, like in terms of time complexity, and they will be using Robin-Karp algorithm. However, that I think I will have a separate video on like those like string matching algorithm. Like we have Robin-Karp, we have North Morris Pratt. We also have like Bayer Moore and like Aho Korasik. So we have a bunch of algorithms coming in like in this like string matching like problem. So I want to talk about those topics like next time. So when I talk about Robin-Karp, I will be using this same problem or maybe else, and then see how it is faster than dynamic programming approach. So let's look at this problem statement. So here is the problem statement, and as usual, I want you guys to pause this video for a second and try to come up with your own solution before we look at my solution together. So first approach, dynamic programming approach. As usual, the first thing you have to think about dynamic programming, like when we talk about dynamic programming approach, we have to know how many states we have to consider. Like at every transition, we have like how many states we have to consider. The recurrence relationship between each like transition. So when we are going from one transition to another, like how is our recurrence relationship works. And yeah, so let's look at this problem. So the hardest part is always defining your dynamic programming. So in my case, we have two states, right? We have array 1, we have array 2. So I just label that as nums underscore 1 and nums underscore 2. My DP of s comma k is the maximum length of subarray that appear in say nums underscore 1 up to but not including s, and up to but not including k for nums underscore 2. So remember in Python, when we have something like this notation, we do not include this endpoint, right? We include all the numbers starting from 0 all the way to s minus 1, but not including the s itself. So how should we so we have to somehow take this into account. And well, we can just create our DP table. We typically do something like what we have, the dimension of row will be length of nums 1, and then the dimension of column will be length of nums 2. But instead of doing that, we just have length of nums 1 plus 1, and then for column we may have like length of nums 2 plus 1. So we just add one additional row and one additional column to our DP matrix, and then that's it. That's for that problem. So here is the code for this, and you can see that this is really short like code. So we have an answer set to 0, and then every time when we are iterating, we will be updating our answer variable by taking the maximum. And yeah, that's for this video. And if you want to know why, like how this DP works, like if you look at this one, this is the DP matrix for this problem, and you notice that we are going from here to here and from here to here, right? So we have so that's how this is moving. And so we have this topological like structure in this our DP matrix. So yeah, so let's see how our code runs for this problem. So here is the code for this problem, and let's run this. Yeah, so one thing that I want to point out is that like 6 months ago when I did this problem on my own, like the first time I tried this problem, actually it was last year. So in 2021, when I had exactly the same method, like same code, I think I got like something like like 55%, like faster than the Python 3 like submissions, but I mean, I can see that this is getting a little bit slower. So for the next video, I will talk about another way of solving this problem, and that is using the Robin-Karp algorithm. So I will have that video for the next time. And yeah, so that's for this video. And yeah, so I mean, the runtime isn't that great, but I mean, this one works. And yeah, so I will see you guys next time. Yeah, so when I did this again, I get 55.95%. Yeah, I mean, this is just the Leetcode, the way Leetcode is. So yeah, I will see you guys next time. Okay, bye bye.